Hello everyone, I am Sagaram. I am the student from Institute of Aeronautical Engineering. An assignment report of operating system. Today our topic is dependability analysis of fuel tolerant computer systems using dynamic fuel graphs. Introduction to dependability in fault tolerant systems. Dependability ensures that computer systems operate correctly and reliability over time. Fuel-tolerant systems are mm, dis- dis- designed to continue functioning despite component failures. Dynamic fuel graphs are powerful tools for analysis and improving system dependability. Importance of dependability analysis. Dependability analysis helps identify potential failures points in the senior system. It enables the design of system that can maintain prof- profin- performance under fault contents. Ensuring dependability is critical for safety, critical and mission critical applications. Fault tolerant computer system overview. Such systems in correspondent redundancy and error detection measurement, measurements. They aims to provide system failure or minimize its impact. Example include uh, aeroport systems, media devices, and functional inference. Fundamentals of fault graphs. Fault graphs models are relationships between component failures and system failures. They they visually represent how faults propagate through system components. Fault graphs assist in understanding fuel independence and system vulnerabilities. Dynamic fuel graphs explained. Dynamic fuel graphs extend systematic models by incorporating temporal, temporal behavior. They account for changing system stage and involving fuel containing containers over time. This dynamic perspective impacts the across of dependability assessments. Components of dynamic fuel fault graphs. Nodes represent system components or specific fault stats. Edges illuminate fault propagation path and dependence. Tom- Temporal attributes capture the times and sequence of faults. Concluding dynamic fuel graphs identify all critical components and their failure models, define temporal, temporal relationship and fault propagation sequence, use system models and historical data to inform graph concept contractions. Fault propagation analysis. Analysis how falls in the one concept and may trigger failures elsewhere. Understand the contradictions under which failures essential or get contacted connected. This analysis builds fault mitigation structures. Relatability and availability methods. Dynamic fuels graphs enable components of relatability over time. They faculty the es- estimation of system availability under failure connections. Matrix derived support design, making for system design and maintenance. Here we can see mm, dependability in various types: security, availability, reliability, safety, resilience. You can see in the diagram as shown below. Next, benefits of using dynamic fuel graphs. They provide a detailed understanding of fault incidents over system lifetime. Support proactive identification of critical components. Enhance the design of more reliability and dependability system. Case study: Aeros- aero, aerospace system. Dynamic fuel graphs modeled the failure propagation in an air, aircraft control system. Analysis identified key vulnerability and redundance points. Result impacted improved. System design for higher dependability. Challenges in dynamic fuel graph analysis. Complexity increases with system size and failure modes. Accurate temporal modeling requires detailed system data. Computationally, resources can be significant for large-scale systems. Next, tools and techniques. Model-based approximates faculty the creations of dynamic fault graphs. Simulation and probabilities analysis helps access system dependability. Software tools like Faultry, Place, and ProFAS can be adapted for system dynamic modeling. Future directions in dependability analysis. Introduction of dynamic learning for um, predictive fault modeling. Development of automate tools for dynamic fault graph counteraction. Enhance visualization techniques for better interpretability. Summary of key points. Dependability analysis is essential for fault tolerant system design. Dynamic fault graphs provides a comprehensive view of fault behavior over time. Applying this model impact improvement improves systems resilience and safety. Conclusion: dynamic faults graphs are valuable for understanding complex failure inter- interactions. They supports designing systems that are robust, agent, derives fault, serious correction, research will future advice, dependability analysis techniques. Reference. Thank you for attention.